Hello everyone, welcoming you to Shorup's classes. So today we are going to discuss the IIFT Economics Entrance Exam 2019 paper, question number 12. Suppose in an economy the demand for capital is driven by KD equals to 80 minus 8R, whereas the supply of capital is given by Ks equals to 6R plus 10, where R denotes the price of capital. Suppose the capital price is flexible and the total capital endowment in the economy is 50. Then the units of unutilized capital in the economy is given by. So you have the demand for capital equation, which is 80 minus 8R, your supply for capital equation, which is 6R plus 10, and the total available capital in the economy is 50. So since R is flexible, so what will happen at equilibrium? KD will be equals to Ks, which means 80 minus 8R equals to 6R plus 10. 80 minus 10 equals to 6R plus 8R. So 70 is equals to 14R. So what is R? It is basically 17 by 14, right? 70 by 14, which is 5. So that is the rate of equilibrium rate of interest prevailing in the economy. That means at this, so what is the equilibrium amount of capital? You just place it in maybe the supply equation or demand, whichever one is possible. So 6 into 5 plus 10. So that is 30 plus 10, which comes out to be 40. So at equilibrium, 40 units of capital is used and the rental rate in the economy is 5. The total endowment stands out to be 50. So the unutilized capital is basically 50 minus 40, which is 10. So unutilized capital is 50 minus 40, which is turning out to be 10. And that is clearly option number T. So this was a very simple question per se. Okay, thank you. So now moving on to the 13th question of the IIFT 2019 Economics Entrance question paper. So let us say that the production function is given by yt equals to kt to the power alpha lt to the power 1 minus alpha, where alpha lies between 0 and 1. Yt denotes the aggregate output, Kt denotes the physical capital, and Lt denotes the labor force. Now assume that the savings in the economy are given by the rental income and the wage income is consumed. Then the non-trivial steady state for capital per capita in the economy will be given by K star, and which of the options are there. So over here, note one thing, it's not really the standard solo calculation that we need to do. There is an additional thing that they have explicitly mentioned, that the savings in the economy are given by the rental income and the wage income is consumed. Okay, that means basically, what is the rental income of the economy? If R is the rental rate and K units of capital are used, then R into K is basically your rental income. This is your rental income, right? And this is equals to your total savings, that is capital S. Okay, so just so that the notations don't have any confusion, let's say I put a S tilde over there. The total savings basically. This is our total savings. Okay, and the wage income is consumed. What is the wage income over here? Let's say that the wage rate is W and L units of labor is used up in the economy. So W into L is the wage income. And that is basically equals to your total consumption. So let's say that is capital C, and just to avoid any notational confusion, let's say it's C tilde. So that is your total consumption. Okay, this is what it basically says. So now if you remember, So the production function is given as k to the power alpha L to the power 1 minus alpha. So what do we do? To get it in per capita form, we divide both sides by L to the power 1 minus alpha divided by L. So small y is basically small k to the power alpha, where small y equals to capital Y by L and your small k equals to capital K by L. Plain and simple calculation, nothing too different. Now, if you remember over here that S tilde over here is the total savings. So what is the per capita savings? If I denote it by small s tilde, it is basically R into capital K by L, which is R times small k, right? So this is the per capita savings. Per capita savings. And if you remember the standard solo um, law of motion of capital that we get, that was k dot equals to s into f of k minus delta plus n into k. Right? Do you remember this? This is what the equation was basically coming out like. Now, understand this over here. What was S? It was the savings rate. Correct? And so what was S into Fk? It was the per capita savings. So this is basically your S tilde. The total savings is basically investment in a perfectly competitive setup. So this is the per capita investment, which is small I. Correct? And this is the depreciation to capital, so which is known as the break-even investment. Fine. So now with all this information, can we have some idea of what is our per capita your K star or in the steady state rate of per capita capital? Now from competitive setup, now if you remember from your standard Cobb-Douglas result, what is your share of capital? It's alpha basically, right? So alpha is equal to K into MPK divide by Y, isn't it? At equilibrium, comparative equilibrium, MPK is R. So this. So if you divide both sides by L, numerator and denominator, you basically get this. So R times small k divided by Y is equals to alpha. That means R times small k equals to alpha times Y, which is over here alpha times f of k, right? So that means in our case, k dot is equals to the per capita savings minus delta plus n into k. Now what is S tilde in our case? It is R times k as I have shown you, minus delta plus n into k. And what is Rk? Given the competitive structure, it is basically alpha times y minus delta plus n into k. Therefore, at the steady state equilibrium, k dot is basically 0. That means alpha times y equals to delta plus n into k. And what is y over here? Given the Cobb-Douglas function, it is k to the power alpha. Correct? So k to the power alpha minus 1 equals to delta plus n by alpha. That means k star is equals to delta plus n by alpha divided by 1 by alpha minus 1. So if you look at the options, it's basically okay. They have used the notation n1 over here, that doesn't matter. So that is basically option number C, n1 plus delta divided by alpha raised to the power 1 minus 1 by alpha minus 1. So that is your option number C for this question. Thank you.